Alright, so here we go. We're going to spend 2 days on section 9.2, so 9-2. Day 1. We will be factoring, so this is your first day of factoring, using the distributive property. So you're used to using the distributive property forwards. You have something in front of parentheses, and you multiply that to whatever's inside of parentheses. Well, this time, you're going to have to come up with what's in front of the parentheses and what's left inside the parentheses. And we're going to use the reverse distributive property using things that you've done in the past, all the way back from September. So the first thing I need you to note is, what is a factor? I've talked a lot about factors. Factors are two or more expressions that multiply to give a polynomial. So you have to come up with these factors, only they're not going to be the factors that you came up with in the past 2 days. So for instance, example 1, the directions might say divide. So this is something you've done before. So the problem is 8x plus 12 all over 4. Does anybody remember what we did with this problem to divide? Say that again. Didn't we split it into 2 fractions and then did the division? So if both of these are over 4, then that means I could split them. 8x would be over 4 plus 12 would be over 4. So split that into 2 different fractions and then reduce if possible. You're going to find that it will work. What's 8x divided by 4? So I get 2x, and what's 12 divided by 4? Plus 3. So when they say divide, that's truly your answer. But what I want to show you what happened was, you're going to come up with this number down here, and you're going to do the division, and you're going to actually end up factoring. It's called the greatest common factor. Isn't the biggest number that divides into 12 and 8 4? And do they have any x's in common? No. So this is actually the greatest common factor that you've been given. You're going to come up with that yourself based upon all of our work over the last 2 days. Now, I just want to prove to you that if I take this 4, because technically, if I take something and divide it by something and I get an answer, should I be able to take that answer and multiply it by what I divided by to get what I originally started with? For instance, what if I had just 8 divided by 2 is equal to 4? Shouldn't the product of those two equal 8? So doesn't 2 times 4 equal 8? That's all we're going to do here, but with a little bit more complicated numbers. So we're going to take this and put it over here. So I have 4 parentheses, my 2x plus 3 in parentheses. This is actually the answer you're going to end up coming up with by the end of this lesson. So let's go ahead and distribute. What's 4 times 2x? 8x. And what's 4 times 3? Plus 12. Isn't that what we started with? So that's how you can check to see if you're correct. So if the question asks you to check your answer, you just take these and multiply them together and see if you get what you started with. Alright, so example 2, I want you to do this on your own. Use your exponent rules. So you've got divide. So we've got 15 x squared y cubed minus 45 x y squared all over 15 x y squared. So I want to physically see you turn it into 2 different fractions and then reduce each of those fractions. When you divide like bases, what do you do with your exponents? Add subtract, or multiply? You subtract. So go ahead and split it and reduce. Compare your answer with those around you. Compare. You should be done. I want all backpacks, purses, and additional binders that don't need to be on your desk off. All that should be on your desk are whatever you need to take notes with and your note spiral. And of course, no cell phone down. All right, the 15 here, both of those cancel. This X is a smaller one, so it cancels up there with one of those X's. Aren't you left with an X only? And then these two Y's cancel with two of those Y's, and you're left with a Y. So this whole fraction reduces to XY. Then minus, how many times does 15 go into 45? 3 times, so I get a 3 here. These X's just cancel completely, and so do the Y's, don't they? And this is my final answer. Now I want you to check it. So check it down here. You perform the check. So when you multiply what you divided by the answer that you got, which is what I'm doing here, we ended up with what we started with. So we're correct. So questions on that? That should be a review of what we've done before. All right, so the next thing, I definitely want you to write everything down that I write, because there's several steps to it. So flip it. Example 3. You are going to use the reverse distributive property to factor each polynomial. So we're going to do 2 different problems together. So here's your first problem. You're going to write some notes to yourself down the side here. So we're going to start with 15x plus 25x squared, something fairly simple. So the very first thing that you need to do, step 1, you need to find the GCF. And I'm going to put here of the whole group. So we've got 2 items in our group. So when we went over homework today, we talked about the shortcut. So I'm going to put the prime factoring of these above here. So 15, isn't that 3 times 5? And then we have an x. We'll talk about that in a minute. And then 25 is 5 times 5, so isn't it 5 squared? And then we have an x squared. So what numbers do they have in common? They have 5s in common, right? So this is step 1, your GCF equals. We know they have at least 1 5 in common. How many 5s can I take away from both of these and take the same amount of 5s? 1. So I can only take 1 5, so I choose that one out of my 2 choices for either 5 or 5 squared. I choose 5. And then they don't have a 3 in common at all, but they do have x's in common. Are you going to take 1x away from both of them or 2 x's away from both of them? 1. So again, I choose that x to go on my GCF. And so isn't my GCF just 5x? That's the biggest number I can divide both of them by. And so then step 2 is going to be to actually perform that division. So step 2, divide each term by the GCF. This is always going to be the very first step you take in any kind of factoring problem. So I'm going to actually divide this by 5x and divide this by 5x, and I want to see you showing that. Because if you do it in your head, you're liable to make a big error. And then, so we'll go ahead and do that down here. Well, I guess we'll do it here. What's 15 divided by 5? 3. And then don't the x's completely cancel, right? And then what's 25 divided by 5? 5. And then what's x squared divided by x? This cancels with one of those and you're left with just an x. So that's the result after I divided by 5x. But this isn't fully factored, this is our quotient or our answer to our division problem. So that's not the answer that I'm looking for. So step 3, I want you to write the GCF. That's what we found in number 1, in front of the parentheses. That's the part you're going to forget. And put what's left over, which is from number 2. That's our answer to our division problem. From number 2, inside the parentheses. So you're essentially performing your check without actually doing it. So step 3, your GCF of 5x goes in front of your parentheses, and inside your parentheses is what we had when we divided. This is the answer that I'm looking for when I ask you to factor out the GCF or use the reverse distributive property. We're not necessarily going to write out all of this stuff for the next one, but that's what we're doing. So let's look at another one and see if you really truly understand it. So B. We're going to do it all over again. This time we have 12xy plus 24xy squared minus 30x squared y to the 4th. So we're going to find our GCF first. Can you look at 12, 24, and 30 and just know what's the biggest number that divides into both of them? We'll start with 12 and 24. They're the smaller two. What's the biggest number that divides into both of those? Bigger than 6. 12, right? Does 12 divide into 30? No. All right, so then try 6, right? If we divide this by 6, what do we have left? A 2, so remember that. If you divide this by 6, what do you have left? A 4. And divide that by 6, what do you have left? A 5. Does 2, 4, and 5 have anything in common that you can divide them by? So doesn't 6 appear to be the biggest number? So we can shortcut doing the prime factor trees if you can do that. So that's all right. So our GCF, the biggest number that divides in there is 6. And then look at your x's. Do they all have an x in common? What's the most number of x's I can take away from each one and take the same amount? Just 1. So I get a 6x. Do they all have y's in common? What's the same number of y's that I can take from each one and take the same amount? Just 1 y, because this one only has 1 y. I can't take 2 y's from this one, or 4 y's. So the smallest number is typically your restriction. So my GCF is 6xy. So then step 2 says to divide that out. So I'm going to go ahead and divide each one of these by 6xy, 6xy, and 6xy, but I'm going to remember to put that 6xy out in front of my parentheses. If you don't immediately do this, it's highly likely you're going to forget. So then go ahead and do your division. 12 divided by 6 is 2, and then don't both the x's and the y's cancel out on the first term. And then 24 divided by 6 is what? 4. So I have plus 4. The x's completely cancel. What happens to the y's? This one cancels with one of those, and you're left with just a y. And then minus, what's 30 divided by 6? 5. And then this x cancels with one of those, so I get an x. And this y cancels with one of those, so I get y cubed. End of parentheses. This is the answer that I am now looking for. But can't you redistribute in your head and multiply the 6xy into here to see if you end up with what you started with? So you can do a mental check. Are you all right with that? Any questions? Okay. 2 more examples. So then you're going to have a couple of things. You're going to have several items where you're doing this. So I want you to try your GCF, try to find your GCF. If you have to use another sheet of paper on your homework tonight, then you'll need to do that. Because you might have to do factor trees for some of them. If you can do it without factor trees, that's fine. If you look inside here, like let's say that I ended up with an x, and an x squared. Wouldn't you know that you forgot to take out an x? So you want to look at inside your parentheses and see, did I take out the biggest factor that I could have? You know, maybe, maybe not. This could have been a 4, an 8, and a 10. So if you look at that and you realize, oh, they're all still divisible by 2, I need to take out another 2, you need to do that. So make sure that you look at what's left in parentheses to see, did I take out enough? Then you're going to have to do some solutions, because the whole point of factoring polynomials is so that we can find solutions to something that is not a linear equation. So you guys found solutions to 2x plus 10 equals 5, right? True or false? So remember, when we found solutions to a linear equation, something that looked like this. So here's my grid, and I had, a line on here somewhere. Whenever this line, or whatever line we're looking at, crosses the x-axis, that's going to be called a solution. So on this particular line, this point right here is going to be called a solution of that equation. We don't just have lines. We could have a curved line. A straight line, we could have a curved line. So if I have a curved line like this, this is what I'm preparing you to solve. This thing is called a parabola. And on this parabola, the parabola crosses the x-axis here and here. What are those points on the x-axis? What's that value? They are solutions, but what's the value? This is 0, 0 right here. So what's this point on the x-axis? -5. So this is -5, and what's this point? 2. So the solutions for x are -5 and +2. That's what we're trying to find with anything raised to the second power. So this might be something that looks like this. So the equation of this parabola, it comes in this form, where your highest degree term, did I put a y there? That should be an x. Whoops. Your highest degree term here is an x squared. Prior to that, we looked at y equals mx plus b, correct? Wasn't that linear? The highest degree term here was to the first power. So now we're moving into, how do we solve something that's called a quadratic to the second power? Notice that it was to the second power. How many answers did I have? 2. You're going to find out in the next unit, unit 10, whether this parabola opens up or opens down. But for right now, I want you to focus on the answers that we're going to get or where that curve, that parabola, crosses the x-axis. So, what if I gave you this, and this is what you'll see in your homework. Example 4. You are to solve. And your problem is going to look like this. X minus 2 times 4x minus 1 equals 0. You're going to get to the point where you can do this yourself. but for right now, you're going to be given this today. So if something times something equals 0, a product equals 0, what do you know about either of these two? One of them has to be 0, right? This could have a value of 4. So long as this has a value of 0, what's 4 times 0? 0. This could have a value of 253. So long as that has a value of 0, 0 times 253 is going to give you 0. So my point to you is this. One of these two has to equal 0, or possibly both of them, right? So if that's the case, and you might want to write this as a note to yourself, the only way to get an answer, because this is vital. Now I can't spell today. To get an answer of 0 when multiplying is if one of the factors or both is or are 0. So I use that word factor. X minus 2 is a factor. 4x minus 1 is a factor. Why? Because they're being multiplied to each other. So anything that's being multiplied to each other to give you an answer, they're a factor. So we no longer are looking at factors like 2 and 36 multiply to give you 72. 2 and 36 are factors. Well, these are multiplying to give you 0. This is a factor and so is that. So if one or both have to be 0, wouldn't it make sense that I would take this factor separately and set it equal to 0? Can you solve that linear equation? How? What do you do? Solve that equation. What do you do? Add 2. So I'm going to add 2 to both sides. And don't I get a value of x is equal to 2? What's 2 minus 2? 0. 0 times anything is what? 0. So it doesn't matter what this is, because this, if x is 2, turns out to be 4 times 2 is 8. 8 minus 1 is 7. 7 times 0 is still 0. Try the other one, because we actually have 2 answers. Set 4x minus 1 equal to 0 and solve that. You solve it algebraically. Tell me what you get. Everybody solve it on your own. This time x is equal to 1/4. Well, first of all, what's 2 minus a fourth? We'll do it backwards for a minute. What's 2 minus a fourth? 1 and 3/4, but because the 2 is bigger, isn't it negative 1 and 3/4? Okay. What's 4 times a fourth? 1. What's 1 minus 1? So what's 0 times negative 1 and 3/4? 0. Does it work? Both, if x is 1/4 and if x is 2, they both make that equation 0. So therefore my answers are, I have 2 of them. If x is 2 or 1/4, it makes it true. So here's what I want you to start to understand. What does that mean? That means, so over here, draw a little coordinate grid. That means that I'm going to put a point on the x-axis at 2. So I'll put a point here at 2. And put a point at about 1/4. So 1/4 would be really close to 0. And label them as 2 and 1/4. All this means is I have a parabolic curve, a parabolic curve. It either opens up or down. I'll show you how to tell that later. But it goes through the x-axis at 1/4 and 2. I need you to make that connection that that's what we're finding. Because you're going to have to graph these in the next chapter. Yay. But first you need to know what those solutions are. So these are solutions to a graph. All right, do this one on your own. And this is the last example for today. Well, maybe I won't let you do this on your own. It's a little hard. So example 5. What if it's not factored for you and not set equal to 0? what do you do? Normally, no, I'll let you go today, but that's what your breaks are for, and I'm almost done. I'd suggest you wait if you can. So this time I have 4y is equal to 12y squared. Is one side set equal to 0 like the previous problem? Yes or no? Yes or no?
No.
Thank you. So the very first thing I have to do, step 1, get one side equal to 0. That's your very first step. Find your highest degree term. Which one of these two is your highest degree term? What's the degree? Yeah, what's the degree of this term? What is it? 1. What's the degree of that term? 2. That has the highest degree and it's positive. I always want my highest degree term to be positive. So it's already positive. I'm going to move the 4y to the right. How do I move terms from one side to the other? In this case, I'm going to subtract, right? So at its opposite. So I'm going to subtract a 4y from both sides. The 4y is not a like term to the 12y squared, so I'm not going to line them up. It completely cancels on this side. So what's the value on this side, on the left side of equals? 0. Isn't that what I was trying to get? And then write these in descending order, 12y squared minus 4y. So ignore the 0 for right now. Look at this. We need to factor it. So step 2, factor out the GCF. So look at 12 and 4. What's the biggest number that divides into 12 and 4? 4, right? So the GCF is equal to 4, and then do they both have y's in common? What's the most amount of y's I can take away from both of them? 1y, right? Not 2. I can't take away 2 from that one. I can only take 1 from each one. So my GCF is 4y. So I'm going to divide this by 4y and this by 4y, just like we did in the previous problems on the other page. But remember, you're going to put that 4y in front of parentheses. And I still have equals 0. Perform that division. What's 12 divided by 4? What is it? 3. And then what's y squared divided by y? Y. What's anything divided by itself? 1, right? But it's a -1, you're right, because of the negative in front. So again, I have a product. This times this equals 0. Doesn't that mean that either this is equal to 0 or that is equal to 0, according to our discussion from before? So then set each of your factors equal to 0 and solve. So I'm going to set the 4y equal to 0. You solve for y. Divide by 4 to both sides. What's 0 divided by 4? It's 0. And then set the 3y minus 1 equal to 0 and solve that. So you're going to get a lot of fraction answers. It's highly possible. I get 3y is equal to 1 and divide by 3. So doesn't y equal 1/3 here? So again, what that means, I'm going to create a little coordinate grid here. So this one is really squished together. So 0 is right here on the x-axis. This is 0. And wouldn't 1/3 be about right here? Again, you don't know if it opens up or down. So we're going to just assume for now that they always open up. And so that's what the equation, that's a sketch of what the equation of that graph would look like. I'm going to show you how to get a better sketch than that later. But for right now, we only care about the solutions, which is where it crosses that x-axis. Any questions? All right, tonight it gets excessively difficult. If you do not grade your homework, I'm going to be upset with you. And you're going to be upset with yourself when you take that first quiz and you don't do well. You need to find out on a daily basis how you're doing. So not only are you going to correct it, and if I were you, I would correct my homework in pen. Do your homework in pencil. Go correct it in pen. Why? So you can see the mistakes you're making. And then not only that, but I want you to go fix the answers in pen until you can get the right answer. If you don't understand it, circle it, and then those questions go up on the board.